Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. The Greenland crater under the Hiawatha Glacier. On November 14, 2018, a paper by Kurt Keyer and 21 co-authors in the journal Science Advances announced the discovery of a crater in the northern part of Greenland that was buried under the Hiawatha Glacier. The paper received wide coverage in the media because scientists speculated that the extraterrestrial impact that made the crater could be related to the extinction event in North America and the onset of the Younger Dryas cooling event 12,900 years ago. The study of the Greenland crater was kept secret from the time that the existence of the crater was suspected in 2015 until the publication of the paper in 2018. Announcements of extraterrestrial impacts are vigorously and acrimoniously contested, so it is not surprising that the scientists decided to withhold information about their discovery until all aspects could be verified. No news were leaked from the time that the paper was submitted to the journal until its publication 11 months later. The research team used a twin-propeller DC-3 aircraft equipped with a state-of-the-art ice-penetrating radar owned by the Alfred Wegener Institute for Polar and Marine Research in Bremerhaven, Germany. 3 flights in May 2016 added 1,600 kilometers of fresh data from dozens of transits across the ice. The radar revealed an impact crater with a diameter of 31 kilometers beneath Hiawatha Glacier and 5 prominent bumps in the crater's center, indicating a central peak rising about 50 meters high. The bottom of the crater was jagged, which was interpreted as a sign of a recent impact, since an old crater would have been scoured smooth by the action of the glacier. The topography of the terrain was based on airborne radar data obtained by NASA from 1997 to 2014 and from radar data obtained in May of 2016. In this image, black triangles represent elevated peaks in the rim of the crater. Dark purple circles in the center represent peaks in the central uplift. The black circles outside the crater show the location where 3 sediment samples were collected. The high compressive forces of an extraterrestrial impact create planar deformation features in quartz crystals. These deformations can be seen under a microscope as lines with different orientations using polarized light. Some critics have pointed out that the shock quartz was obtained outside the crater rather than within the crater. The research team plans to get additional samples, but argues that the crystals that they tested were brought from within the crater by a meltwater stream. Thus far, every sample that contained shock quartz also had elevated concentrations of nickel, cobalt, chromium, platinum group elements, and gold, which are indicative of a relatively rare iron meteorite. The diameter of an impact crater is related to the kinetic energy of the projectile. The formation of a 31-kilometer wide impact crater in crystalline target rock requires approximately 3 × 10⁻21 joules of energy. Assuming that the Hiawatha impactor was iron with a density of 8,000 kilograms per cubic meter and its impact velocity was 20 kilometers per second, the required impactor diameter was about 1.5 kilometers. The researchers assumed that the impactor was an iron meteorite because iron meteorites were previously found in Greenland, although the exact composition of the meteorite that made the crater is not known. Ground-penetrating radar made it possible to get a view of the crater without the glacier ice. As an additional bonus, the radar images contain bright reflections at the boundaries of grit from ancient volcanic eruptions. The research team matched those bright layers to the same layers of grit in ice cores from other parts of Greenland. This technique revealed that most ice in the Hiawatha crater is perfectly layered through the past 11,700 years, but in the older, disturbed ice below, the uniform bright reflections disappear. The deep jumbled layers were dated to 12,800 years ago, which makes it possible to conclude that the Hiawatha impact crater was formed at or before the Younger Dryas. Some experts doubt that the impact occurred as recently as 13,000 years ago because statistically, impacts the size of the Hiawatha crater occur only every few million years. Professor Jay Meloche from Purdue said to the Science Journal, "This is a hot potato. You're aware you're going to set off a firestorm?" Paleoclimatologist Jennifer Marlon from Yale University said that the Greenland crater is too small and too far away to kill off the Pleistocene mammals in the continental United States, and that she can't imagine how something like this impact in this location could have caused massive fires in North America. Soon after the Greenland crater was announced, many researchers drew a line between the Greenland crater and Saginaw Bay, which has been proposed as the impact point for a meteorite that hit the Laurentide ice sheet, ejecting ice boulders that killed the megafauna and created the Carolina Bays. The distance between the Greenland crater and Saginaw Bay is 4,000 kilometers. Notice that the Nastapoka Arc on the east side of Hudson Bay is along the line. With the Earth tilted at about 23.4 degrees from the ecliptic, the line from the Greenland crater and Saginaw Bay is inclined about 60 degrees from the ecliptic plane. Future research will be necessary to determine whether there are any comets or meteor showers with that inclination. If the Greenland and Saginaw Bay impacts are related, they would have occurred within 7 minutes of each other. The Earth's orbital speed is 30 kilometers per second and its diameter is 12,742 kilometers, so the comet debris would have had to be in a fairly tight cluster. Otherwise, multiple impacts would not have occurred due to the Earth's speed. The Nastapoka Arc is a prominent, near-perfect circular arc covering more than 160 degrees of a 450-kilometer diameter circle on the east side of Hudson Bay. The arc is very suggestive of an impact crater, and the islands in the center of the arc seem like the remnants of a central uplift of an impact. The Nastapoka Arc has been studied previously as a possible impact site, but the results were negative. The idea that the Nastapoka Arc is related to the Younger Dryas event has a long history. In 2009, Richard Firestone suggested that an impact or extraterrestrial explosion in the Great Lakes or Hudson Bay could have been responsible for the formation of the Carolina Bays and the Nebraska rainwater basins. The Younger Dryas was followed by meltwater pulse 1b from 11,500 to 11,000 years ago. Sea level increased by as much as 28 meters. The single extraterrestrial impact in Saginaw Bay that created the Carolina Bays was not sufficient to account for meltwater pulse 1b. If the Greenland crater is confirmed to have formed at the onset of the Younger Dryas, perhaps the two impacts, plus others that have not been found yet, could account for the 28-meter sea level rise for meltwater pulse 1b. This is an exciting time. This is a time of vindication for all those luminary thinkers who have been arguing for the existence of advanced antediluvian civilizations and for the sinking of Atlantis as a historical event rather than just as a fictional legend. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.